You're listening to the Seasteading Today podcast, where we speak to entrepreneurs and researchers who are making the dream of seasteading a reality. The Seasteading Today podcast. Stop arguing and start seasteading.
Hello, Seasteaders. This is Carly Jackson on the Seasteading Today podcast. My guest today is Dr. Patrick Takahashi, a retired engineering professor who has been advocating for the Blue Revolution for a third of a century. In 1979, he wrote the original legislation for ocean thermal energy conversion, or OTEC, and hydrogen fuel production when he worked in the U.S. Senate. Dr. Takahashi explains how we can generate clean, renewable energy. Otech is such an exciting technology that would allow seasteads to build independent economies. This conversation was inspiring to me, especially as a fan of science fiction. I could easily imagine the future floating city where people eat fish and seaweed and generate energy without polluting the ocean. And now, the conversation with Dr. Patrick Takahashi. Welcome, Dr. Takahashi.
Aloha, Carly.
So the Seasteading book describes you as an OTEC enthusiast. OTEC, O-T-E-C, stands for Ocean Thermal Energy Conversion. Will you explain what that is?
Yes. If you go to any portion of a deep ocean and you put a pipe down 1,000 meters or 3,000 feet, you will contact cold water. The water is about 4 degrees centigrade, roughly 39 degrees Fahrenheit. And if you have a pipe to bring that surface and you combine that deep ocean water temperature fluid with surface waters, which are warmer, heated by the sun, you can produce electricity. And while you're producing electricity, you can also produce fresh water. So generation of electricity and production of fresh water are just two natural products from this renewable cycle that can go on essentially forever. The exciting part about the deep ocean water is that what grows at the surface of the ocean, microbes, they die and they drop towards the bottom of the ocean and they decompose into the exact mineral composition that is needed for growth at the surface. So here you're bringing up, with the cool, you're bringing up free fertilizer where you can initiate growth to start the cycle from phytoplankton all the way up to fish and more. At the same time, while you're doing that, you can be fertilizing a farm of seaweed or marine biomass. And so you have a system that if it's in the open ocean, if you want to start a new city in the open ocean, the land is free because it's the ocean and no one owns it. What you need, of course, is a platform to do this. And that platform is what will be the beginning of the Blue Revolution.
So just to reiterate, an OTEC platform that's bringing up cool air or cool water, generating energy, and producing food, and a byproduct is fresh water. So you're getting energy, food, and water from one technology.
Right. And with the electricity that you'll generate, you can produce hydrogen. With the growth in the ocean, you can have industries of biopharmaceuticals. And so it's almost like magic. You can produce all these renewable products. And it's also within the realm of reality that this cycle that we're creating, you might have to add a little iron maybe, but you can take up carbon dioxide from the atmosphere. And most energy sources tend to produce waste products. In the case of ocean thermal energy conversion in the Blue Revolution, you're actually enhancing the environment. And if you put these platforms where hurricanes form, you will increase the temperature of the ocean by a degree or two, which means that hurricanes will not form. And so we have a system that's environmentally a positive, you might say, while you're producing these sustainable products for the future of humanity.
That sounds just incredible. And it's so exciting. And when I was first reading about this in the seasteading book, I just want to know, okay, why isn't this happening all over the ocean already? Is that a fair question to ask you?
Yeah, it's a very fair question. When we put together the first OTEC bill, and it was in 1979, as you said, we speculated that in the year 1999, there will be 10,000 megawatts of OTEC. Here it is 20 years later, 2019, and really we don't even have 1 megawatt of OTEC. And the reason is because there is a gap problem. If you produce iPhones, each one that you test is fairly cheap. If you design and construct a, say, 10 megawatt ocean thermal energy conversion facility at sea, it'll cost you $100 million. And so how do you take that step from today, which is almost nothing, to 100 megawatts and 1,000 megawatts? That is a problem. The first one to be built is a high-risk venture that companies will not take, although Lockheed is talking to China about it. Governments will not seriously consider because they have other options like wind power or solar photovoltaics. Ocean thermal energy conversion will make it someday. The question is, will it be in a few years or will it be in the next century? And that's the problem with the blue revolution. It's really a blue evolution right now. And the only way you can get over this hurdle, this first step, is to find as seasteading did, the inspired billionaire to initiate the effort. This we have not succeeded in accomplishing.
Did Bill Gates work on something or produce a?
Bill Gates was working with I forget his name from Stanford, but and also with Salter of Scotland to try to prevent hurricanes, and they had this ship that took water from the deeper ocean and sprayed it into the surface, essentially cooling the surface of the ocean. Now, the problem with doing that is that you're not making any money. It takes a lot of effort to build a ship and to build the equipment, and all you're doing is preventing hurricanes. In the case of the Blue Revolution, the one difference we have is that the whole system will make a profit. And so while we're enhancing the environment, like preventing hurricanes or remediating global warming, that entity is making a profit. And this is sort of like related to seasteading. Everything you're doing from step one has to be profit making. Mm-hmm. Everything we're doing in Blue Revolution Hawaii, we know is not going to make money for the next 10 years. But somebody has to do the basic fundamental science and engineering to gain the confidence of someone who's going to finance it to bring it up to the 100 megawatt and 1,000 megawatt level. And if you had a chance to look at my recent postings on, say, the ultimate Blue Revolution, you would have seen what has to be involved. And that has not been close to being accomplished yet.
So can you go into some details? Well, my first question is, why isn't it possible to start with a small component, with a small seastead that can just draw the water up and for cooling, and then just slowly grow from there? Why do you have to start with such a big structure and infrastructure?
The reason is if you start with a 1 kilowatt device, like on a tabletop, it's very inefficient. You have to go out to a megawatt for it to become somewhat realistic. And at the 1 megawatt level, you're already talking about millions of dollars. Mm. So who's going to come up with the first few millions of dollars? And government and companies are not prone to do it because at this small scale, the electricity costs and the fresh water you produce will be too expensive. And so we need to get over the hurdle of a desktop device or even a home-sized device and get into the open ocean with at least 10 megawatts. And 10 megawatts will cost a lot of money, many millions of dollars.
And you said the depth needs to be 3,000 feet.
3,000 feet is just ideal to get the right temperature. Now, if you are needing of this deep ocean water just to start a marine biomass plantation or a next generation fishery, you only need to go down to about even less than 1,000 feet because the nutrients increase very rapidly until it gets to about 1,000 feet. And then it stays high, but it doesn't increase anymore as you get down to 3,000 feet. So then how do you get the electricity or the power to bring this deep ocean water from, say, 1,000 feet to the surface? You might use wind power to do that, but you cannot use ocean thermal energy conversion because at 1,000 feet, the temperature is too warm. So you have to get down to 3,000 feet to complete the full cycle.
So let's talk in more detail about each piece of this, the energy, food, and water. So with the energy, correct me if I'm wrong, my understanding is the change in the temperature of the water can propel like a windmill. Is that correct? Or propel?
Yes and no. The answer is mostly no. And here's how the Otech process works. The deep ocean water comes to this is pumped up, and the pumping is almost free because when you get something called hydrostatic head, there's not much involved in energy in bringing the water to the surface. This cold water is used to looking at the warm water side. You lower the pressure of the warm water side in the heat exchanger, which creates a vapor. And what the system is that this vapor moves through a turbine, and the turbine is generating the electricity at the same time as the vapor from the warm water side goes through a heat exchanger and gets cooled by the deep ocean water. You get both electricity and fresh water. Mm-hmm. So it's kind of hard to say looking at the graphics, but you can go to any location on the internet and you can see how it's done. It's doable because the temperature differentials are relatively small. We're talking about 39 degrees versus maybe 80 degrees from the surface, 40-degree temperature differential, which is very low, which means that the efficiency is very, very low. So you need huge devices, and this is where the cost comes in. But once you get to a certain level, say 1,000 megawatts, it becomes competitive with many of the other renewable options. How to get there is the problem.
So once you're generating this energy, who is using it? Do you need to transport it or somehow to land-based communities?
Someday you can beam it to land, or you can certainly use cables, but then you have to be close to land for that, several hundred miles. However, if you have a floating platform that's an industrial park or floating city in itself that will house 1 million people with all the structural connections. That's the ideal for the future of the Blue Revolution. It's not to bring energy back in the form of electricity or anything to land. It's to build future habitats and future locations that can, while it's profit making and people are living there, will enhance the environment. And the question is this 20 years away or 100 years away? And to get there, it's going to take some time.
So as long as you're building machinery to go and draw up water from 3,000 feet depth, so then if you can also get the carbon, phosphorus, and nitrogen that's on the ocean floor and pull that up,
right,
that can be used to grow seaweed, and can also support other sea life that can be used for food.
Oh yeah, you can close the growth cycle, say for a type of fish that feeds at a low nutrient level. And one of the examples I use, which almost scare people, is something called the whale shark. Okay, the whale shark is not a whale; it's a shark. And as it is, we're killing too many sharks just for the fin. But the whale shark is an interesting species because a mother gives birth to something like 200 babies. And if you compare that whale shark mother with a cow produces one calf probably. And if you look at the cycle for how steak comes together, whale sharks someday might replace land cattle. And so that's one example. And the reason why the whale shark is of interest too is that it feeds at a very low trophic level. It consumes zooplankton. And so you can produce a lot more mass with a low nutrient level seafood species, as opposed to if you were trying to have a tuna farm, which is too inefficient.
So yes, if you would explain a little bit what trophic level means. There's a lot of discussion of that in the seasteading book, but if you had a short explanation for listeners, that would be helpful.
Yeah, the trophic level is essentially when you let me use as an analogy farming on land. You grow corn, you fertilize it to make it productive, and you irrigate it for the water. In the ocean, the water is there; it's free. If you have the deep ocean fluids coming up, it'll be at the right ratio of phosphates and nitrates and potassium compounds, and you can nurture growth and support it through the whole cycle. The trophic level has to do with, at the beginning, there's zooplankton, and no, there's really phytoplankton, which is the small plant life, and then zooplankton consumes the phytoplankton. With each layer higher, you lose a factor of 10 in the nutrients. So therefore, the zooplankton is consumed by small fish, and the small fish is consumed by larger fish. At each level, you lose a factor of 10 in productivity. And therefore, if you could just harvest the seaweed or the zooplankton, you get the most mass. But if you have to go up to a fish, then you lose a factor of 10 or 100 or 1,000. And so that's the trophic level. The lowest trophic level is one that starts with zooplankton. And a higher one, maybe 1/10,000th as productive would be sharks. However, the whale shark is a shark, but it consumes zooplankton and really some phytoplankton too. So that's the trophic level explain. But again, without graphics, it's kind of hard to comprehend.
Sure, but is it correct to say that that if you had a whale shark ranch,
Mm-hmm.
it would be a lot less expensive than if you were trying to have a tuna fish farm, because tuna fish have to eat fish higher on the trophic level.
Right, exactly. You're going to produce roughly 100 times less biomass or seafood with tuna as opposed to whale shark.
So have you ever seen whale shark on a menu?
No, but in China they eat it. And I've never tasted it, but it is consumed. I'm not saying it's going to replace Japanese Wagyu beef, but it could well be an option to consider in the future. And if it's not the whale shark, we'll find something else.
Well, I know that there are, so we'll be interviewing Neil Sims too to talk about his kampachi. So
now, kampachi is at the higher level, so it's really not ideal for this kind of operation. If you use something like rabbitfish, which eats at the phytoplankton level, you can produce a lot. You can produce about 100, if not 1,000 times more than tuna. And kampachi is up there with tuna, although maybe it's 10 times more efficient because tuna eats kampachi.
So we have these large OTEC platforms floating near the equator where people are living in cooled homes, cooled by the cold seawater drawn up that is also used to power the energy, and they're eating whale sharks and growing seaweed farms. So,
and by the way, the seaweed farm can be harvested to be produced into biofuels, which can be shipped by tanker to land. So it's not like you cannot use anything produced on a floating platform in terms of renewable energy. You can. And of course, the electricity can also be utilized for hydrogen production, which can also be shipped. So someday, as my blog has said, we will have hydrogen plant ships in the air, and like the Hindenburg, except we can design it better so it should not explode. But the future of transportation someday will probably get away from fossil fuel, jet fuel, because one, it's going to get expensive. Two, it produces carbon dioxide in the air, which is terrible. If you can create a future generation aviation system of fast-moving dirigibles, although they won't look like dirigibles, but they could go several hundred miles an hour, you can have, in the future, someday, a totally different air travel service that goes slower, but it's compatible with the environment and might be the only option, because by then oil will be in some peak. We passed the peak oil point a few years ago, but the real peak oil is still coming someday in the future, whether it's 10 years or 20 years or 30 years, it'll come. And almost surely by 2050.
That's a very exciting image you paint there. I'm writing my seasteading novel as we speak that will flesh out this whole future for us. So I wanted to go back to talking about hurricanes. Can you explain a little bit about having these platforms on the equator and why they will prevent hurricanes, or what the mechanism is for that?
Basically, there's a hurricane, Category 4, just off the coast of Mexico, heading for Hawaii today. It's Barbara, and she's heading for Hawaii, but she's going to, at some point before she gets to Hawaii, move north and west. As it moves north, the temperature of the ocean cools. and therefore it'll lose its conformation sometime before getting to Hawaii, so it'll die. Now, these hurricanes do not form off the coast of Mexico or off the coast of Africa in the wintertime because the ocean is too cool. If you can lower the summertime temperature of the ocean where hurricanes form by a degree or two, you can prevent hurricanes from forming. Now, the reason why you want to put the first few floating cities at the equator is because magically almost, because of the Coriolis force, a hurricane has never crossed the equator. So you're safe from major hurricane storms in the equator. Now, someday you might want to control hurricanes, so you're going to get brave and put one of these things off the coast of Africa or off the coast of Mexico, and so forth, and try to lower the temperature sufficiently to prevent hurricanes from forming. One will not do it. You might need 10 for all I know, but the calculations have not been perfected yet for exactly how much cooling by how many million size floating platforms can do it. And this is what Bill Gates and his partners have patented by taking deep ocean water up and spraying it to the surface. But again, they're doing it and not producing any products, just preventing hurricanes. This system will be profit-making while it's hopefully going to reduce, if not prevent, the formation of hurricanes.
So one of my favorite quotes in the seasteading book is that seasteads do not need to be afraid of hurricanes. Hurricanes need to be afraid of seasteads.
That's right. But your seasteads are almost all being planned for hurricane zones. I don't know of any seastead that has been proposed for the equator for right now.
Right, because it's too far away from land.
Too far away from civilized areas that you want to link to.
Well, people are starting small with their first seasteads, and then hopefully we'll scale up.
You can go anyway, so it makes sense.
Sure.
And this is why you need a reasonably large first of its kind. And we call the first experimental structure Pacific International Ocean Station. It'll be maybe 10 megawatts. It could go up to 40 megawatts, and it will cost $150 million or so. Who's going to come up with the first $150 million? And then after you do that, and let's say it works, magically it works, then you want to try 1,000 megawatt facility. That's going to cost $150 billion. $150 billion.
Well, so you said the first one starting with 150 million. So I'm looking at all you recently rich Bitcoin owners start investing that and saving up to create this first Otech plant on the equator. I did want to ask you about your time in...
Carly, before your question, let me just quickly add that there have been two monumental world accomplishments recently. Recent meaning like in World War II, there was the Manhattan Project that really ended the Second World War. And then later on this month, when was it? In 1979 was Apollo. And the cost of Apollo in money today is roughly $300 billion. Okay. So it was monumental. But what it did was it essentially bankrupted the Soviet Union. So it ended the Cold War, and it was worth the cost. And this is why I am amazed at how the rich people of the world today, they're still enamored with space. Apollo was necessary because there was a political need to neutralize a mortal enemy, the Soviet Union. To go to Mars today is almost unnecessary, if not useless, if not dangerous. If we can get these space billionaires to look at the ocean, it's a lot more productive for both the planet itself and humanity, of course. So with that, you can ask me a question.
Well, that's a great segue into it, because you've spent some time in DC and had worked towards getting attention towards this OTEC energy production. So can you tell us about your experience in DC and how bringing about these platforms through that legislative process?
Well, it's amazing how life unfolds, because in 1979, by then I was an engineering faculty member at the University of Hawaii, but I was working at the Lawrence Livermore Laboratory on laser fusion, because my PhD is laser building, actually. And I was in this laser fusion program in 1979. It occurred to me that laser fusion, or any fusion, was beyond my lifetime. And so I thought it was a nice experience at Livermore, but it was just going to take a very, very long time, almost like the Blue Revolution. And there was nothing I could do to help that technology, because there were smarter people doing the work already. But there was a second energy crisis in 1979, if you can recall, with President Carter and Iran and so forth. The price of gasoline really the supply of gasoline was such that there were gas lines. There was a time when I was asked to go work for Senator Matsunaga in Congress, and he happened to be on the right committees, Energy and Natural Resource and Finance. So we were able to initiate various types of renewable legislation. We joined with the House to produce the first wind power bill, which led to the American Wind Energy Association, and all that's happened to the point today where wind power is just about the cheapest form of energy, comparable to natural gas and cheaper than coal and nuclear. So, that's one accomplishment that we've had. But we also, Matsunaga was the first to introduce an Otech R&D bill. And also he was the first to introduce the hydrogen bill. And Otech is long-term. Hydrogen is going to be a little longer term, I suspect. But these options will happen someday. The question is when, but they'll happen.
So are the bills something that keeps being brought up in front of Congress to be reconsidered and redebated, or is it something that is live?
No. Like, for example, both the OTEC and hydrogen pieces of legislation became laws. It's in the books. It started the hydrogen program to the point where, at the time when George Bush the younger was president, this is unbelievable, but the hydrogen budget was actually bigger than the solar technology budget. I mean, the solar technology meaning like PV and those mirror versions of generating electricity. If you look at the solar technology per se compared to the hydrogen budget was actually bigger. Now, hydrogen budget has dropped considerably because the promise is not there right now.
And the government funding of this research, how do you see that affecting the actual market and of entrepreneurs trying to build businesses that create hydrogen energy and can use it?
Well, renewable energy is very similar to global warming. Companies will just not do it. It just, why take from what they're doing now? So you need a catalyst, and the catalyst is the government. The catalyst, the U.S. government built the atomic bomb. It sent people to the moon. It initiated much of the renewable energy programs that now companies have taken over. The problem with the Blue Revolution is that the gap between the research and the reality is too wide. With photovoltaics to what you see in your rooftops, the gap is narrow enough that companies have come in and taken over. And of course, wind power, the same thing too. How to get over the gap is a problem with the Blue Revolution. And the person who will gain a legacy, who starts this effort, will someday become a hero.
Have you seen progress in actually getting an Otech plant built in the last couple of years since the seasteading book was published?
The answer is no. The reason is this. The closest any partnership got was Lockheed. And Lockheed, by the way, was a company that built this mini Otech facility that generated electricity from the ocean just off Keohole Point, where the current National Energy Laboratory Authority is. And the ship on which Lockheed succeeded in doing it was obtained through Senator Matsunaga from the Navy. So Matsunaga had a hand in Lockheed's success. So Lockheed has been involved since 1979. More recently, 5 years ago, they signed an agreement with China to design and build a facility. The reason why this has not happened is because 5 years ago, no, when was it? 7 years ago, whatever it was, maybe it was longer. The price of oil had shot up to $142 a barrel. And then it's stuck around between $100 and $125 for some years until it kind of crashed down to $50 and less more recently. And 5 years ago, the crash had begun to occur already. The price of oil is today too low to enable options like Otech to compete. And I suspect that's why Lockheed and China have kind of stopped doing much.
So it's a matter of waiting for that
time,
price, that cycle to
right,
raise the price of oil again.
And the price of oil will go up. I mean, no question in the next 10 years it's going to go past $100. So is it going to be next year? Is it going to be 10 years from now? Who knows?
Well, I'd like to bring our conversation to a close and ask, how can people find you? Or do you have a website or anything to promote?
Well, the best thing is to go to my blog. It's a long blog, and I'm not sure how to give it to you by audio.
We will definitely.
You know, if in the address bar you just put in my name, Patrick Takahashi, and comma, Planet Earth and Humanity in one word, you'll get to my blog site.
We'll definitely link to that in the show notes page when we publish the episode. And I just want to thank you so much for joining us. I'm sure we could have talked a lot longer. Is there anything you'd like to add?
Oh, no. I'll give my best to all still there at Seasteading. I do meet with them every so often in San Francisco. I look forward to my next activity with them. I applaud what they're doing. We're heading in the same direction, but they're doing it with profit in mind. And my current mindset is that the next 10 years will have to be R&D as opposed to real profit. And this is why we need that group of billionaires to take it over that hump.
All right. Thank you.
The Seasteading Today podcast is produced by John Bush. Your host is Carly Jackson. Send feedback and questions to podcast@seasteading.org. To support the podcast and the Seasteading mission, go to seasteading.org/donate. If you'd like to learn more, read the book, Seasteading: How Floating Nations Will Restore the Environment, Enrich the Poor, Cure the Sick, and Liberate Humanity from Politicians. Be sure to subscribe to our podcast feed, and we'll save you a spot on a seastead.